Hi class, Dr. Betts here. Welcome back to Chemistry 1032 Lab. This is Unit 4, Density. Density is mass over volume. So we're going to learn to do a few different techniques to determine the mass and the volume of different objects and determine their density. Very fun lab, very simple to do, but very fundamental. Part 1, density of a regularly shaped object. A student, that's you guys, will learn how to calculate the density of a regularly shaped object. Now, in all things, for the most part, mass is easy to get. Density is mass over volume. As long as you have a digital scale, you can get mass. It's pretty easy. The hard part is volume. Getting the volume of an object is not always easy. But for a regularly shaped object, such as a cube, or say a cone or a cylinder, you can calculate that with math. Just measure the length, the width, and the height of a cube, multiply it through, and you'll get the volume of the cube. Very simple. But in part 2, we're going to take things a little bit more challenging. We're going to make you do the density of an irregularly shaped object. Now what do? Well, we're going to learn a pretty cool technique called volume by displacement. Very cool, very fun. Part 3, density of a liquid. Very simple. We're just going to calculate the density of a liquid. Again, mass is fairly easy to get. Just put liquid on a scale. Oh, wait a minute. How do you put liquid on a scale? Not that bad. We'll get to it in part 3. Part 4, density of solid objects. Now, this is something you're going to do at home. You're going to do basically a test with water to compare densities of everyday household objects to water. Very cool, very easy. Part 1, density of a regularly shaped object. Again, density is mass over volume. So when determining mass, you just basically put something on a scale. It's very simple. And read the numbers off the scale. So, very simple. No sense belaboring that point, right? Let's move on. Now, volume of a regularly shaped object is determined by what we call direct measurement. You measure the length, the width, and the height of something. If it's a regularly shaped cube, you can determine its volume. Just multiply it through. Now, in this example, you're measuring in centimeters. So it'll be centimeters by centimeters by centimeters. And the final unit will be centimeters cubed. Just so you know, 1 centimeter cubed is actually the same as 1 milliliter. They're the same amount. Easy enough, right? 1 centimeter is 1 milliliter, pardon me. So you measure the cube, all 3 sides, multiply through, get its volume in centimeters cubed. You have its mass. Divide the mass by the volume, you have its density. All right, guys, now that we've heard about part 1, let's do an example of what we need to do. Here we have a blue box with some dimensions written on it. We call it the object. And the question says, what is the density of this object if it has a mass of 55.345 grams? All right, very good. Now, the first thing you need to know is that density is mass over volume, often abbreviated. It's mass over volume, often abbreviated M over V. So the mass of the object is clearly written in the question. So that's 55.345 grams. Divide that by the volume. Now, we don't know the volume, but we do know the dimensions of the regularly shaped object. Remember, volume is length times width times height, or 7.65 centimeters multiplied by 3.40 centimeters. Multiply that by 2.76 centimeters, and that will give us our volume. Now let's grab our handy dandy calculator. 7.65 multiplied by 3.4 multiplied by 2.76 equals 71.8 centimeters cubed. Now, centimeter cubed is a milliliter. So 1 centimeter cubed, let's just write this up here, 1 centimeter cubed equals 1 milliliter. They are the same amount. So you can just simply plug this number in here. 71.8 centimeters cubed equals, again, bust out your calculator, 55.345, divide everybody by 71.8 equals 0.771 grams per centimeter cubed. And that's how you calculate the density of a regularly shaped object, knowing the dimension. Okay? Part 2, density of an irregularly shaped object. Again, the mass of the object, just put it on the scale. The irregularly shaped object's volume, however, we'll have to determine with a technique called volume by displacement. And here I'm kind of showing you how to do it here. You take a graduated cylinder and you put a known volume of water in it. So you put some water in it and you measure that volume. That's called VI, the initial volume, the volume that you're starting with. And then you're going to submerge the object whose density you're interested in, whose volume you want to know, you need to know. You submerge it, and of course, as you submerge this object, the water level increases. Why? Because the object is displacing the water. The water in this case is dyed green so you can see it, but you don't have to dye it green. Now, VI, the initial volume. VF is the final volume, the volume that you get once the object is submerged. Now, you've all done this experiment at home. You just didn't know it. When you get in the bathtub, you don't fill the bathtub up to the rim of the bathtub with water, because as soon as you get in, the water is going to overflow the tub, right? Nobody wants that to happen. So you don't fill it quite as much, because the volume that you're putting in the tub, you, for example, is going to be displacing the water in the tub. Okay? So, again, initial volume is what you start with. Final volume is what you end with. Okay, guys, now that you've heard about volume by displacement, let's put it into practice by measuring the density of this little puppy dog toy right here. Now, density is mass over volume. So D equals M over V. As always, mass is very easy to determine. It's usually given in the question. Not always, though. Sometimes you have to figure out the mass. But mass, you throw it on the scale. Put the object on the scale, gives you a mass. It's pretty simple to find if you have a scale. The volume is often the more tricky of the two things to figure out. Now, we have this puppy dog here, this toy puppy dog. We want to know its volume. So we're going to submerge it into this water. And the volume of the dog will displace this water, giving us a larger volume. The device will actually read more volume, and that's because of the volume of the dog. And we'll get a final volume. So the volume will literally, the volume in the graduated cylinder will literally go up. Okay? It'll literally go up. So let's get another formula here. V object equals VF, volume of the final, minus VI, volume of the initial. All right, initial is before you start. So let's go to the first cylinder. First cylinder, we'll take a look at the meniscus up here. It looks like 38.0. So let's write that down. VI equals 38.0 milliliters. Do not forget your estimated digit. It is very important. VF equals, so here, go to here to read the meniscus. I'm going to say it's 38.9. So I made a mistake in my first measurement. Oops. $38.9. Yeah, seems about right. Now I made a mistake here. Most of you probably caught it. It's not 38, Dr. Betts. Cross that out. It is 28. I can already hear some of you yelling at the screen. Thank you for your help. I'm sure some of you are trying to help me out through the screen. That's great. Hey, we all make mistakes. Good thing is we caught it early. So 38.9 is our final volume. 28.0 is our initial volume. Subtract 28 from 38, and you get 10.9. And that goes right there. And that's going to give us 15.345 divided by 10.9. It's going to give us a density of the toy dog at 1.41 grams per milliliter. And that is the density of our toy puppy dog. In part 3 of this experiment, we're going to measure the density of a liquid. Now, measuring the density of a liquid is the same as every other experiment. You just need to know the mass of the liquid and its volume. Again, mass is fairly easy. You put a container on the scale, pour the liquid into the scale, and now you know the mass of whatever you poured in there. The volume is the trickier part, but we have tools to work with. We have graduated cylinders. So here we have a picture of a graduated cylinder, and the volume in that cylinder appears to be 41.8 milliliters. So the volume how do I know that? I simply read it off the device, 41.8 milliliters. Density is mass over volume, and that's going to give us 38.999 grams. That came from here, came from the question, divided by 41.8 milliliters. Bust out your handy dandy calculator. And you get 0.933 grams per milliliter. Okay. In part 4 of today's experiment, we'll be looking at the density of solid objects. To do this, we'll need a cup of water, fill it about halfway. At least leave an inch between the surface of the liquid and the top of your glass. You'll also need some small household objects, maybe a bottle cap, a coin, maybe a paper clip, maybe a small piece of wood, like a small pencil. Anything that could either float at the surface of the water or sink to the bottom of the water. And what you're going to do is you're just going to place the object in the cup with the water. If the object sinks, it's more dense than water. If it floats, it's less dense than water. Now let's take a look at an example we've all seen. Ice in water. Ice floats on the surface of water. Why is that? Because ice is less dense than liquid water. So it floats. It always floats. And you've all seen that. Anything that's more dense than water won't float. It will simply sink to the bottom. And that's how you can do rough estimates of densities on things around your home. All right, guys? Now with that, I want to wish you all good luck and good chemistry. We'll see you soon.